So welcome everyone for joining us today. We're going to be talking about some of the challenges that many of us have when we are responsible for a Salesforce org from a DevOps perspective as it relates to analyzing static code. And today we have the CodeScan team with us. We have Nitai and Ben who are going to walk us through a little bit. First of all, even explaining some of the challenges associated with analyzing static code and showing us some of the different options available for analyzing your static code, and also showing us how CodeScan can help make that analysis way easier. And so Nitai is going to be explaining more conceptual, and Ben is going to be helping by actually showing us exactly how it works with some screen sharing. So I'm really excited to have them here with us. I think this is a fantastic learning opportunity for everyone. So with that, Nitai, it's all you. So go ahead and you can feel free to share your screen whenever you're ready.
Perfect. Thank you so much, David, and thanks everyone for joining. When I first started at CodeScan a few months ago, the first thing I realized is that static code analysis is not a standard practice for all the developers teams out there. So I was very curious to understand why. And the second thing is that once you decide that static code analysis is something that you need for your team, you don't know exactly what is best for you, because there are so many static code analysis out there, but there is one that is specifically good for you. And it's not always CodeScan. Most of the cases it's CodeScan, but not always. So I think that here we can shed some light on what is the right static code analysis is for each organization. So this is where we come from. Cool? So I will share my screen, and we will run through a couple of slides here, and Ben can help me with the technical aspect when we step into the system. But feel free to jump in and ask some questions. David, if you get anything on the chat, just let me know and we can stop. And I think you are muted, and we cannot hear you.
Yeah, I just put a message in the chat, just sort of calling it out to everyone, that if anyone has any questions whatsoever, if you could just put it in the chat, I'll sort of be like the Vanna White as Nitai and Ben are showing us some of the magic that they have for us. So if you have any questions, just feel free to just put it right into the chat, and I'll call it out to make sure that any questions are addressed.
Perfect.
Yeah.
Sounds good. So before we start, and I'm sure everyone knows, but everyone knows what a DevOps is. But just to make sure everyone is aligned, we play into the DevOps area. And DevOps, in our opinion, is just the practice of operational excellence. And their main purpose in life and in a company is to shorten the development cycle while you keep delivering high quality products. So they do it by putting a lot of gates and quality gates and standardization in order to shorten that development cycle, but keep the product flowing. So we are just part of this process by enabling them and empowering them with the technology to scan their code and reduce the time for the code review process. So we give them a technology instead of doing that manually. So in today's world, the DevOps is slightly different in Salesforce than it is for other development platforms. So for Salesforce, as you know, it's extremely easy to change that. Every admin, every person, sometimes even the users are able to change Salesforce, but not always these changes are contributing to the system. The other thing is that the technology is evolving. If you would speak about Salesforce 5 years ago or even 10 years ago, the way the DevOps processes were in Salesforce and the technology out there is completely changing and completely different than it was before. Same for the static code analysis tools. And the other thing is how many groups are collaborating together in the development process. So you have the developers, you have the admins, you have the project manager, the program managers, and all of that are just making the DevOps process much more complex than it is in other platforms. So in that case, the static code analysis can solve a lot of things. But the main challenge that static code analysis is coming to solve is the situation that we all face with. And we all know that the later the bugs are found, the more expensive they are to fix. So in a quick experiment that we conducted, if you find a bug on after you push that into testing, for example, it costs you 25 times more than if you just find it on doing the design process. So this is exactly where a very smooth development DevOps process can save you a lot of money using the technology. And something is happening through the development process. So we notice a lot of situations that developers that are not using technology for testing and QA are developing their things in the development environment. And then they believe that this is a finished product and they push it into testing and QA. And then here they are going over the code and all of that, and they are bringing that back to development. And then again, they push that again, and they bring that back to development. And that loop is causing product to slow down the deployment. It costs a lot of money to the organization, a lot of frustration to the developers. So a static code analysis tool is coming between the development and the QA and also in many other stages to just make sure that you define those standards, you define how you want your code to look like, and then everyone is getting aligned into that point before they push that into testing and QA. So I think that with that, I can hand it over to Ben to show us just a use case of a customer and how would they use a static code analysis tool in their process to define those gates and scan and find those vulnerabilities and bugs and issues before the QA process. Ben?
Am I coming through?
Yeah.
Cool. So,
Yes, we can hear you, Ben.
Great. So I'm just going to share my screen. Let me know when you can see it.
Yep.
Cool. Thanks, Nite. So CodeScan, we have a hosted version of CodeScan. So you can run CodeScan either on-prem, so in your inside your company's LAN, or use our cloud version. So this is a typical homepage for you. So basically, you have a list of projects. So a project is a code base, really. Some people use different projects to look at their code in different ways, either be it completely separate projects or different versions of it. So yeah, so we can see here that list. So let's just take a step back for a second, and we'll just run through how you might work with this. So first of all, I won't show it to you now, but developers can start by actually developing, if they're using like Visual Studio or something like that. While they're writing their code, they can actually get these results that I'm going to show you in the IDE as they're developing, and that's probably a topic for another time. But it's a great saving. Like as Nite pointed out, if you can capture the problems earlier, i.e., while you're typing the code, then it will improve that cost saving. Okay, so the next step after a developer has made some changes is either they save it in Salesforce and in the metadata API, and we can directly work with that metadata API. But another way of working for some developers is to use a GitHub or something like this. And typically what happens in that way, and this really depends on your company, how you do it, and we support lots of different ways of doing it. But a pull request is a great way of working, because what you do is you as you work, you commit, and you bundle together the changes for that one feature that you're building, and you put it into what's called a pull request. So here's like a basic example. Like, okay, we've just introduced one function, complete rubbish, obviously. Now, so you commit that that code, and you create what's called a pull request, and then we can, you know, in GitHub you're able to comment on it, leave some information about it. But what CodeScan does is it'll link into GitHub and take all of the code that you've changed and analyze it and feedback that information back here onto the pull request. And actually you can have the pull request be in a failed state if I don't know if I've got an example of one here. No. But it'll basically put an X next to the pull request and say, hey, you know, you're not, this code is too bad, like inverted commas, to merge, and you should fix it before you go ahead and merge it into production. So so let's jump over to what so CodeScan is this. So we'll come here and we'll see actually what that information it is that it's checking. So we go into that project that was linked up to GitHub, and this is something that you might see. Actually, I'll just jump here for a second. So here is an example of a branch to the code base that we've just checked. So and we can, this is not the same bit of code, but here we can see the code that has changed in this particular branch, and you can actually dig into that code and see what's being done. So so here's an example. This is a JavaScript check of doing something that you shouldn't be doing. Yeah, so you know, we're overriding some standard functionality here, which you shouldn't do for JavaScript. The string is an internal object. So we check Apex, JavaScript, Visualforce. We also check inline JavaScript. So Visualforce, a lot of people write their JavaScript directly into Visualforce, and we also check that. We also got, we'll jump over here, back here. We also have checks for CSS, so you can even check your CSS, make sure that you're following certain patterns. And there are actually quite a lot of other languages that we support, if that's what you're doing. We also have checks for certain checks for metadata, things around record types, object permissions, things like that, security settings. So it's yeah. So let's jump back back to what we would see in a typical project. So when we scan that information, we've got all of the issues and things that we've discovered in the code, and here's a list of those issues as some examples. So we've got some more examples here in an Apex class. Got some. We haven't specified the sharing rules. We've got an Aura Lightning entry point here without any security, like a. Normally you should have a try catch with a special kind of exception so that it deals, that Lightning can deal with that correctly. And here we've got a security error that we're not doing any sort of security checking on it, a permission checking rather. So that's a few examples of the issues that we have. We have, like, I should have shown that to you when we were back here. Sorry. But we've got over 200 Apex rules, 227, a lot of JavaScript rules, 100 Visual Force Lightning rules and a few metadata rules. Just so you know, if you have this CodeScan installed locally on-prem, then you can actually also build your own based on our libraries. All right, so here, so we've got the overview here. We also pull in code coverage, so you can see overall code coverage and unit tests, and you can see you can drill down into all of these things. You can drill down into. We can see here are the failures. So we can actually even, let's see if there's an error here that we can see. Sometimes you can see, yeah, here. So you can actually see that the error where a unit test has failed. In this case, which is kind of cool. So another area that that is kind of cool is that we're pulling in a lot of metrics, and we can actually not only see the lines of code and code coverage and things like that, but we've got this concept of complexity. So a complex code is difficult to maintain. The harder it is to maintain, the more it costs you in the long term, because the next developer that comes along is going to find it difficult to understand what is in that code. So code coverage, i.e. how much you test your code, and complexity, there's a relationship, right? Difficult code should be tested more because obviously, well, I don't know if I don't know if I need to explain that more, but basically, here is a chart that shows the relationship between complex code and code coverage. You know, here we've got a large piece of code with only 19% code coverage, and it has a cyclomatic complexity of 110. So it's complex. It's one of the most complex classes, and it's one of the least coverage. So we could go in here. We can see probably that there's a lot of loops, a lot of if statements, a lot of logical things, and I can bet you that all of these different operations are not being tested correctly. In fact, you can see that they're not tested at all. So what's to say that all of these rules work as you'd expect? Anyway, that's so going back to this chart, if you were going to do some refactoring work or some additional work, you'd want to choose classes up here to sort of improve on. So as a manager, you'd want you can look at these sort of high level things and decide how good is my project, you know, where are the areas that I can focus on to improve the maintainability of my code. So that's kind of it. I wasn't going to do a lot more than that. David, what do you think? Is there any areas that we want to look at further?
Yeah, we have a couple of questions. So first of all, Joseph asked, could you tell me what are the differences between CodeScan and check marks?
Yeah.
I saw this question. I think we're going to touch that in the next few slides. And this is exactly what we are going to discuss, not only with check marks, but many other static code analysis tools out there. Yep.
Because we have another question about Metazoa, so I'll pause on that. Lior was able to respond to a question regarding Capado. Another question was, can CodeScan also scan MeleSoft apps and flows?
I haven't worked with MeleSoft before, but I believe it's Java based. Am I correct to ask that question?
The question was asked by Arno. He said yes. Yeah.
So yes, there is an out-of-the-box bunch of rules for Java. So as long as it's just sort of general Java type stuff, there's absolutely there's a lot of rules. This is not something that CodeScan maintains. It's just it's an open source project. we pull in a lot of other stuff. So yeah, so yeah, I guess it does. I guess it would help for sure.
We have another question. Utkarsh has quite a few questions. So he's asking whether or not can we integrate CodeScan with Capado AutoRabbit in order to automate the scan?
So it sounds like Lyra might have answered this question, but yes, we are working with Capado. We have an integration with Capado. We did that probably a year ago, I think. We've been so yes, and AutoRabbit, I believe, has an integration in the works, so it's being built as we speak. So yes, so these tools are great companions with CodeScan. So because what you want to do, and maybe I didn't really touch on this before, was that as you're developing, it's actually you want to actually block your code from going into production if certain criteria in CodeScan are not met. So we call that a quality gate. So a quality gate, you can actually build your own quality gates, and you can use any of the metrics you've seen, including obviously simple stuff like test failures, but also, okay, we don't want to merge if there is more than X number of duplicated lines, or in new code that has been scanned, or there's not more than X number of critical issues, or you get the idea. So we can gate the code from continuing into production. So an example of a quality gate, I think I sort of showed it before. So here on this new code that's come in, this branch that's come in, we've failed the quality gate on this step here. So we can feed that information back, and we do feed it back to GitHub, Bitbucket, and pull request sources like that. And you can actually subscribe to it through a webhook. But integrations like Capado will be able to actually put a flag into the build process and say, hey, maybe you shouldn't merge this because this quality gate has failed. So yeah, so you can sort of put more governance around the quality of your code when you use a build tool like that. So yeah.
Very cool.
Yeah.
Michelle asked a question of, does this tool give the ability to test in a sandbox and set breakpoints to debug, showing the contents of the different variables, etc.?
This is not a development tool; it's a static code analysis tool. So development tools are do the things that you mentioned. Static code analysis tools do what, as the name perhaps suggests, that it statically looks at the code. So we pull the code down and we look and we scan through. We create, basically the way it works is we create a massive tree of all the code, and then we scan through that code looking for patterns that might indicate a security problem or a bug or a code quality issue. So so that's what CodeScan does. Yes, there's some active components, like we pull in the code coverage and several things like that, but it's not an active development tool like you're suggesting.
Yep. Kripa asked, for XSS vulnerabilities, can the tool handle false positives effectively? Any best practices you can suggest?
Yeah, false positives are always a problem with static analysis tools. We try our best to reduce the number of false positives, but because we are looking at the code statically, we can't always tell what the scenario is that's causing the problem. So static analysis is always a balance between false positives and false negatives. Too many. Would you prefer to have too many false positives or too false negatives? We try, of course, to balance that, by not displaying too many false positives, but if you're not careful, you also then might miss things, and that's then a false negative. We use what's called data flow analysis, which basically tries to identify where a piece of information comes from. So XSS, as mentioned, is a security vulnerability where a piece of information comes from an untrusted location, i.e. potentially from a hacker, and is displayed on another page, which is potentially one of your staff members, which could do something evil, like distribute data from, scrape your page and send it somewhere, or something that the original developer didn't intend to do. Obviously, one of your developers wouldn't scrape your page and send it to a third party, but if you could inject a piece of code into your page, like someone clicks on a link and then it suddenly injects that code onto the page, that would be called a type of XSS attack. And so we try to point out the places that occurs. And as pointed out, there are potential false positives because that data flow analysis that I mentioned has many steps along the way, one of which may be checking something which we can't identify that you're correctly checking for that. So that's where false positives can occur. So we try our best, but there will be scenarios where we can't identify the false positive. But again, balance that with, would you prefer to have a false negative?
Yep, all good. So we'll get to one other question, and then we're going to switch back over to Nitai because he's some more stuff to share with us. So the last question that we have, for now at least, the last question that we have is there a categorization in terms of vulnerabilities like low, medium, and high? And also, can we edit the thresholds ourselves? The thresholds proposed are based on OS list of vulnerabilities.
So these profiles these are code quality profiles. So a quality profile is a list of all of the rules that you would like to run in your code base. So here's an example of a rule that the API version is too old, and I can say, you know what, I want to change the minimum version to, I've got to use 44, let's say, right? And we can save that. We can also change what the severity is, which was the question, of that rule, and set it to a different value. That all of those settings are captured inside a quality profile, which can be assigned to as a default, or you can have lots of different projects with different settings. And yeah, so kind of forgot the rest of the question, but I think that
awesome.
Basically, yes, you can. Oh yeah, maybe I'll show you one more thing. Is when you do go, when an issue is raised, you can see this this issue here. For example, add a new line. So normally you put a new line at the end of the code. So you can actually change it at that point and say, you know what, in this particular scenario, it's actually critical. There's a type of another type of categorization, which is it's a bug, a vulnerability, or a code smell. Code smells are neither bugs or security vulnerabilities, but are when the code smells, I guess. It's a weird terminology, I know. And you can flag every issue as a false positive. Actually, that possibly covers that previous question, is that you can manually specify any issue as being a false positive, and then it won't show up. You can also assign it to someone in your team, or write a comment about it on this issue. And as long as that issue doesn't move too far from its original source location, it'll maintain those comments against that issue going forward.
Awesome. All right, let's switch gears back over to Nitai, and there are a couple of other thoughts, comments, questions. If there's time, we'll certainly go back to them. I'm keeping track.
So thank you, David, Ben. That was amazing and great questions. So I take the screen, I will switch back to the slides and keep the questions going and coming. And so I think that by now we understand what the DevOps process is and where exactly the static code analysis fits into the DevOps process. And we also have seen how we can use and take advantage of the static code analysis tool based on all of these rules. But how would you choose the static code analysis that fits for you? Right. So there are 4 things that we put on the slide here that when you go to choose your static code analysis tool, you need to take them into account. The first thing, you want to make sure that the static code analysis tool can scan what the language you are coding in. So there are many static code analysis tools out there that they don't fit into the metadata or the visual force. So if you do a lot of development in visual force, you really limit your options. And Ben showed a lot of things about the rule sets. So you really need to make sure that those rule sets fit into what you are working on, right? So if you are working on X and the static code analysis tool will scan Y, it's not going to help you. The other thing is the integration. So we touched that. We do have an integration to Copilot, AutoRabbit, and Flossom is in the work, and of course the repository is here. So you want to make sure that the static code analysis is integrated into your platforms. And the last thing, like anything in life, is about the budget and the money. So there are many static code analysis tools out there. So probably you've heard some names here of PMD, CodeClimate, CodeScan, Clayton, Checkmarx, SonarQube, and many others. And in the following slides, we'll just show a few of the differences between the tools. Cool? So this is the first thing that I always like to show everyone. So when you go and choose your static code analysis tool, you want to make sure that it has enough rule sets, and this is what we see here on the y-axis here, enough rule sets to cover your implementation or your code. And the other thing here is how many languages in Salesforce the tool covers. So when you look into PMD, CodeClimate, CodeScan, and these groups, they cover one language in Salesforce, which is Apex. And it's good enough. It's probably most of your code in Salesforce, but it's not everything. And when you move into these platforms here, they cover a little bit more like Visual Force and Lightning Web Components and all of that. And when you go here, this is 100% of your languages in Salesforce. That includes the Apex, of course, Visual Force, Lightning Web Components, and of course the metadata. And this is where we fit in. Okay, so it's important to understand that map when you choose the static code analysis tool. Another map that we have here is how many languages each tool covers outside of Salesforce. So Salesforce is just a small tool or small project for most of these platforms. So I think someone asked about Checkmarx. Checkmarx is a large company. We have a lot of respect to them. More than 500 employees, and they have a lot of. They position themselves as a cybersecurity software, not a static code analysis tool. So static code analysis tool is just a side project for them. And Salesforce or Apex within that static code analysis tool is even smaller than the other things they do. So Checkmarx is providing static code analysis tool for many languages. Salesforce is just a small thing there. And they are moving towards this direction to have more languages into the static code analysis tool. So they are not going deeper into Salesforce, they're going wide into other languages. So when you look into Codacy and Code Climate, they do the same thing. They are adding more and more languages into their static code analysis. And when you look about CodeScan and Clayton, these are the two static code analysis tools out there that are 100% focused on Salesforce. And they are going deeper into the amount of rules that we can build in Salesforce in order to provide a better static code analysis or better scans to our customers. Cool. All right. So if we just summarize that, we'll move everyone else here to that side. So if we just summarize that, I would say that if you're just a small organization, just getting started, and you have maybe 1 or 2 developers, you don't want to spend a lot of money on technology, at least not at this point, and you haven't finalized the DevOps process, I would say PMD is a good option. Probably CodeScan and Codacy and even checkmarks, of course, could be an overkill on that. So we see a lot of companies that are just using PMD because it's free. It's like an individual license and tool, and not an enterprise solution that enables team to collaborate together, like CodeScan, for example. And if you are just a small and medium organization with a low budget, but maybe you are growing, you can probably move into Clayton that provides something more robust than PMD, and it moves from the open source to a for-profit platform. But when you move into an enterprise company that is a large company that well established and has a very good, solid DevOps process, then you need to think about these platforms. If you use only Salesforce and you want to have the highest quality for Salesforce rule set, you don't have a lot of options. CodeScan can technically offer you what you need, but there are other tools here like Checkmarks and SonarQube that can provide you other languages that are out of Salesforce. So we meet a lot of customers that are switching from Checkmarks to CodeScan, or they even maintain 2 tools like Checkmarks and CodeScan, because Checkmarks is really good on an enterprise level to scan a lot of languages, but then the Salesforce team is kind of taking a bullet and compromise on the quality. That's why they are adding another tool, which is CodeScan. There is another thing to note here is the speed that the tool can enable the DevOps, the developers to work on. So we have noticed that, and Ben can speak a little bit about the technicality here, but for CodeScan, for around 100,000 or 200,000 lines of code, it takes less than 30 minutes to run a scan. So developers can go through a code, scan that, fix it, scan it, fix it, scan it, and then push it to QA. We've noticed that in a lot of companies here, and Checkmarks as an example, for scanning 100,000 lines of code, it takes more than 18 hours to scan. And Ben, maybe you can comment on that, but we believe it's part of their security scans and how deep they want to go into a security, because they don't position themselves to have to empower the DevOps process, but mainly into the security aspect of it.
I agree. It's they have positioned themselves more as a security tool than a code quality tool, and although we do security as well, code quality is an integral part of what we think is code quality is something you do all the time, because it's a continuous thing. If you don't have good code quality, maintenance becomes a nightmare, and actually naturally security will become a problem, because if you can't understand what's going on in the code, undoubtedly you're going to have more security problems. So you can kind of, although I'm not saying that that you don't need a security tool. It's very important, but having code quality is almost a separate concern, and certainly it's ongoing in that you can't do a security audit and then it's not like a security audit where you go and fix the 6 things that they point out. This is code quality is a thing. I personally, I develop code a lot, and I personally cannot work without a code quality tool, no matter what language I'm working in. I just it's almost like using a Google Word, Word without Microsoft Word without a spell checker. Like, I don't know about you, but my English is not real good. Is not very good. Anyway, the point being that that you kind of expect it to be there, and you expect that red line to come up when you try and spell strange words.
I think that someone asked before if the rules are exposed and public. So yes, all the rules are on the website, also on our website, and Checkmarks also shared their rule set. And we made a comparison a little while ago. So we made the comparison of these rules, and we figured out that most of the security rules that they have, we also covered in our tool. And we just added on top of that the quality rule set. Yeah. So if we move, so we move into the next slide, but the next slide shows exactly where we position ourselves as we discussed before. So CodeScan is a very enterprise tool that fits into companies in this size that have an in-house DevOps team. They are well established their development process, and we help them just to develop that better, faster, and become much more productive. And this is just some of our customers, but we have customers in all of the industries and of course all the sizes. It's just, we see that as how they respect their DevOps processes and how much they want to invest in their developers by using technology. So companies like American Express, and Barclays on that financial market, and on the healthcare and pharma, Novartis, and all of the big pharma companies that are working very hard to save the world during this time of COVID. Yeah. So we'll get into the last couple of slides, and someone asked how we can get started. This is a really good question, and we have few options here. The first option is to get a very easy, fast assessment of your organization. And we really encourage you to do that. It's extremely easy. You go into codescan.io, you run a quick report. As long as you are admin, you can authenticate yourself, your system with our website here. You choose which environment you want to scan. And in 2 minutes, you get these snapshots. And you get a PDF report that shows you all the things that we have on the dashboard. However, here you cannot drill down into the system and look into the things that Ben described. So it's just a static report that shows you the number of lines you have, the technical debt, the issues and the vulnerabilities that you have here, also code coverage and duplication. So a lot of insights into your organization to see where you stand. The other thing we have is you can go on our website and sign up for a trial. So then you can make your hands dirty a little more and get a full system of CodeScan and integrate that to your repository and start scanning your environment for a couple of weeks. Yeah. So by that, David, I think we are getting into the end.
Yep, absolutely. There are a couple of other, I think actually just one other question that came in, which is from Joseph. Do you have any numeric examples for time of code scanning from small, medium, large? And another question, what is the support model? Case model like Salesforce, dedicated support engineers.
Yeah. So I will take the support model. So the support model is we don't charge on the support. We like to see our customers growing, and we have a free unlimited support for our customers. So all of our customers, they have the phone number, email address, and everything they need, and also a chat online to contact our support team. And they're always happy to help on that. The SLA is super long. Yeah. Usually we see the support working hard on the implementation and the onboarding, but after that, they are almost 100% independent. Yeah. And maybe Ben can take the first question about the time of scanning, right?
Yeah, I'm having trouble. I guess time of code scanning. So does that mean like how many minutes to scan the code base? I think that's what I'll take it to mean how long it takes to scan. So okay, thanks. So anything's less than 100,000. So the most amount of time is generally, so we give an option to run the unit test. So some clients for that takes hours and hours and hours, but that's outside of our hands. That's what's happening on Salesforce. We can also pull in that code. If you run that from somewhere else, we can just download the code coverage information. So if we just talk about the static analysis side of things, under 100,000, we're talking several minutes generally. And over that starts to, if you're doing it on-prem, it always depends on how much memory you give it. The more memory you give it, the faster it'll go. On the cloud version, I've got to say I'm not 100% sure, but we do scale up the amount of memory give it, and stuff generally happens with, we have a hard, strict time limit of an hour, so nothing is ever more than an hour, but I think it's more like 10 minutes or so generally. Now, that said, if timing is important, what we often suggest is that you also use an IDE plugin. So that an IDE plugin, it's instantaneous. So while you're typing, you're getting those results back. So you're not waiting for that loop, that feedback loop. So it's like I said, an analogy before of spell checker. While you type, you see it'll actually literally redline the code that you're working on. Say, hey, you should put a bracket on a new line, or this looks like a bug, or whatever. So they work hand in hand, because there are some situations you can't solve just by looking at one file. That's it. So could we schedule a time of day? Yes, there's a time of day to schedule. If you're using GitHub and Bitbucket, things like that, then it gets scanned as you commit it. So it sees the webhook. So it's basically, as soon as you commit it, we see the change. GitHub tells us, and we scan it and post the result back.
Awesome. Nitai, anything else from you, actually, or Ben, before we wrap up then?
No, I'm just saying, everything is online. Just a quick disclaimer about our presentation here and our competitors. We love them. We respect them. They are doing great for the industry. It's just a matter of which static code analysis is really fit for you. It's like choosing a car. And the other recommendation is try us out. Go online. Most of you guys here are admins, at least in Sandbox or production. Run a quick report, see what it says.
Awesome. Thank you everyone for joining, and I'll see you all in the next video. Talk to y'all soon. Bye-bye.
Thanks a lot. Thanks, David.